Well, hello everyone, and welcome to a new small thing about the inverse square law of which apparently proves a local sun. I found this on Taboo Conspiracy's channel, however it is apparently a mirror from Dream Caliber, whoever that is, I don't know. We should probably watch it on their channel, right? Just to be fair, with a whole 98 subscribers, which is about 30 times the amount I have. So, without further ado, let's have a look-see at what we see. I mean, I'm already leaning out of the window. Again, I'm doing this blind as usual. I'm leaning out of the window here, and I'm saying that they did not use a solar filter because, usually flat earthers don't use the proper equipment to do their observations because, why should they? But the sun, right? It doesn't really change angular size. It does a bit in the early morning and in the late evening when it's right above the horizon, because there the sunlight travels through quite a bit more air, right? And so then it gets squished a little. Usually, it's becoming a bit broader than its high normally. Of course, different weather conditions and localized phenomena can, I assume, influence it. Not that I have observed it, but just saying. I mean, that to me just looked like it. I mean, without the solar filter, of course, because why properly observe it? That just to me looked like it got dimmer, again, partially because it's traveling through a lot of air. Yeah, that does not look too much smaller. That's just you have the glare that becomes less because it's getting darker when it approaches the horizon, right? So that's crap. Yeah, that's true. Yes, that has something to do with how things radiate, right? Imagine that you have a sun, right, or a star in general. You can also do it with a light bulb if you want. And the amount of let's say luminosity that it shoots out, so to speak, it remains the same over all. The total luminosity, of course, has to remain the same in all distances, right? So you think that the luminosity over the surface of the star or the light bulb has to be the same as the luminosity over the imagined, if you will, sphere at a given radius, right? So because the total luminosity is conserved, of course. So that's where the inverse square law comes from. So if you sum up all of the luminosity from a big sphere that's far out, and you should get the same result as when it's close by, because the radiation just kind of stays the same, and it just goes out. It really comes from that one, right? So if you have a sphere here, and you take a short short area here at the distance r, and you increase it to 3r, it goes in a square essentially, because it comes from the surface of a imagined sphere, right? That's where it comes from. I do sincerely hope that this whole video is based on this very shitty observation. That would be so funny if it was. I should probably note that the inverse square law, that you need to think about the inverse square law a lot when you don't have a point source or a spherical source. If you have like an area, yeah, this is, by the way, it's a justification. It's a great justification. If you have, for example, a whole area of things, right? So your source is not a point or a sphere, but kind of if you will, a plane, an elongated plane. That the whole thing becomes a lot more tricky, because then it's not radiating the same amount in all directions, and then this becomes very, very, very tricky, very quickly. Just for that mention. Yeah, I mean that's essentially what I said here. Yes. Why though? It's not a difficult formula, but okay.
I'm going to do a quick demonstration of the inverse square law for light. I have one of those old style over.
I mean, the overhead projector really isn't too great of an example because again, it doesn't shoot out the light homogeneously or like equal in all directions, right? Which is kind of what this, you know. I mean, it's still going to be roughly correct, but here you really need some sort of like the lenses are affecting this, you know. So, but it's fine for a demonstration, of course. It's fine.
A mask on it that has a square cut out of it, so I can project a square up on the board. And right now, the projector is 1 meter away from the wall. So what I'm going to do is I'm going to mark the outline of that square on the wall. And now I'm going to move the cart so it's 2 meters away from the wall instead of 1. This is a 2 meter long stick. And so, there we go. 2 meters away. Again, I'm going to outline.
Yeah, no, that's fine. That's
the lit box.
That seems within reasonable deviations. That seems fine. But I think that we all understand the inverse square law. But I mean, again, I don't have anything against this demonstration. It's a very nice demonstration, actually. I didn't know that this was that obvious, even with an overhead projector, really. But sure, why not?
And I'll turn off the projector.
I'm just, you know, going forwards. Yeah, that's a nice demonstration. I think it's okay. Sure. Why not? Did he say at night? So when the sun's not out, we're going to measure the sun. That's a great idea. Oh, okay, he's not measuring the sun yet. Okay. Sorry, I retract my laughs. I'll just again go forwards. Yeah, that's what you would expect. So, or something similar like that. Yeah. Yeah, it's less steep as you would expect, kind of. Well, I mean, he says rounded. Rounded isn't a mathematical term to describe, you know, functions with. I would say it becomes less steep, or in a way, because what you were essentially seeing here was a 1 over x, right? That's or 1 over x squared, really. And of course, if you make the x squared, like you put a factor in front of that makes it less steep, well, of course your function is going to be less steep. Yeah, you have to use some kind of meter. There are even apps on your phones for that, by the way. My old phone was really nice at that, my new one not so much. There's one called, I believe, that Sensor Suite. There's another one that I have that I kind of measure things. It's mostly for fun, really. I can't seem to find it right now. It's not important. I will drop the name in the in the video description. But the thing is that essentially with these apps or with proper equipment, I'm not saying that you should use apps for scientific measurements. But what I want to say is that you can, with these apps, you can sometimes measure light with the light sensor of your phone, and it's somewhat accurate. I recall that I used to measure the quite big fluctuation of the lights in the auditorium at university, because it was flickering a bit. So you can do that, right? So yeah. Yeah, that would be. I mean, it would be interesting. However, you do have to take into account that the atmosphere, the light, the length kind of the light has to travel through is not going to be constant throughout the day. Squared with approximately 1000 watts per square meter. I mean, I believe the solar radiation constant is 1300 and something watts per meter. Not important. It of course becomes less, as you travel up or down from the equator. Yeah, at the equator it's 1370 something watts per square meter. So if he has about 100, he lives a bit above or below the equator. He might live in the USA or Southern Europe or something. Yeah. Okay, that's cool. Okay, that's in Denmark. Sure. Yeah, that makes sense. That's about what you'd expect. Yeah. Oh no. Okay. So they okay. I see where we're going now. The line of argumentation here is that you have at noon you kind of have your peak value, and as you go down in the miles, that's not miles. Oh, that's time. He was getting ready to do the next one. Okay, sorry. No wait, those are miles. Why would they be 1,000 miles? Okay. Oh, I see what you're doing. So the thing here is, however, that that's not the only thing that influences how much light comes to something, right? The inverse square law really says that if you don't change anything else, but you change your distance, the light will increase or decrease, of course, depending on how you change the distance. That doesn't mean that that's the only thing that can influence it, right? if you have your sensor, imagine that your sensor is a plane, right? And you tilt that plane away from the light source, of course, you will be getting less watts per square meter. And that's exactly what's happening. As the Earth's turning around, the light is being spread across a bigger area, and so of course you're going to get a decrease. So what he's essentially saying here is that this more or less works with both models here. At the very worst for him, it works with both models, right? Also, do you really think that the Earth that the Sun sometimes is at 0 miles? Because that would be a bad day. but I once again I find it amusing that they accept a part of science, and that's the inverse square law, but they don't accept that, for example, you can bounce radar off of the sun, because that's apparently forbidden, if you only take into account the inverse square law, I mean, you know, that will be working somewhat. But again, if you turn from your light source, then the energy, or really the in this case it's power. Watt is a unit of power. If the power becomes more spread, so you know, that doesn't quite work. It's also a bit of a misunderstanding of how the inverse square law is to be used, because you need to make sure that your other parameters stay the same, right? No, really, it you know. But also, like, why would it be? This is probably a well-known thing. Why would it be dark if that's what the sun would look like, right? You should get a small amount every time. Oh my god. Okay. Also, the the uh, the pattern in which the sun is moving throughout the day, and it always has apart from the very early morning and the very late evening when the sun is a few degrees above the horizon. Apart from that, the sun moves in a constant fashion, which it shouldn't do if it was moving like it was depicted here, right? That the sun's movement is consistent with the Earth turning, because if you were to map the position of the sun in the sky at every minute, so to speak, the distances would be equidistant all the time, which is not what you would expect if the sun was moving the way that they say it would move. It does, which is only consistent if it's turning. Again, please use a solar filter. It's the sun's corona doesn't shrink, it's just the glare that shrinks. Jesus. If you could ever get the flat earthers to understand that it is important to look at things with proper equipment. I've seen so many things lately of flat earthers pointing completely inadequate equipment at a star, then having the star completely out of focus and saying, "Oh, that's not what a star looks like." Well, fucking sorry for swearing, but like, come on, even pretend to care. Pretend to care for even a second, please. It would be so awesome. Ah. Again with the glare, it's yeah, that happens though. The sun gets a bit squished in the very morning and in the late evening. That has something to do with the atmosphere and the way that the light travels through the atmosphere. But during the day, it usually stays of constant size, which is also not possible if the sun was moving the way it flat earthers say that it would, by the way. Oh yes, please. I'm curious. I will omit the axial. Yeah, because the axial tilt is part of the explanation there. Well done, well done. But sure. Yes, magic units. You're doing science, of course. I assume I'm fine with all of that. You know, that's fine. If you're doing it for Denmark, I'm okay with that. Mm-hmm. Why did the music stop, by the way? Did I press? Oh, I pressed something. I'm so sorry. Yes, that's the inverse square law, but that's not the only thing that you have to take into account here if you want to measure the power of light that comes in over a given area. Because again, it's going to tilt away from you as it's rotating. Yes, exactly. But it's not. Oh my god. Okay. I will need to illustrate this somehow, right? Is there a web version, please? Thank you. Okay, so the thing that's really important. I'm not doing it with Denmark because right now that's not the issue, right? So it's always the daytime side. Ah, well, that's annoying. but I will be able to make my point. The thing is that right here, which is kind of where the sun is overhead right now, right? As you go to the side, the sun rays to cover the same area will be stretched, and if you come close to the nighttime side of things, this one, the stretching will be so immense that you will drop a significant amount in light. That's what's going on, really. And he's clearly not understanding this because he thinks that uh, uh, that the tilt is not important. Of course, he does a few calculations. I just say that they're correct. I'm just assuming. So really, the point of this video is when you ignore that the Earth is in our model, because he wants to say that in our model it's crap. Yeah. If you ignore that the Earth is rotating and that makes the one individual ray have more area and thus being more spread out, then yes, it would work. Suddenly you need, sadly you need to misunderstand things in order to do that. And with that, I believe that we are done for today. Thank you very much for watching. And Dream Caliber, I would invite you, if you would ever get to see this video, which, let's face it, you probably won't, because I'm a tiny channel. But I would be curious what you have to say about that. Other than that, I thank you so much for watching. Please do consider maybe leaving a like, or dare I even suggest that you consider subscribing. If you do, I would be very pleased. Thank you very much for watching, and with that, I will see you next time. Have a nice time until then, and goodbye.